The German Panther tank was considered the trump card of the Wehrmacht in 1943, and for good reason. Phenomenal frontal armor, a gun that Soviet tankers called the Hand of Death, optics superior to anything the Allies produced at the time. But when this steel predator first took to the field near Kursk, it was not knocked out by Soviet shells. It burned right on the railway platforms before even reaching the front lines. Friends, due to a shortage of archival footage, some scenes in this video have been recreated using artificial intelligence. Enjoy the show! July 1943. Belgorod Station. A train carrying the latest Panthers had just been unloaded. The driver mechanic of the first vehicle carefully begins to drive off the platform onto the ground. The Maybach HL 230 engine roars. The tracks grip the wooden deck, and then a flash. A fuel line had sprung a leak. Gasoline dripped onto the red-hot exhaust manifolds. Fire. The crew barely manages to jump out. The tank never saw a single Soviet shell. It burned up 200 meters from the unloading platform. And this was no accident. It was the first warning that the Panther program was built on compromises from the very start. Compromises that German industry had no business making in 1943. Now, let's figure out where the idea for this tank even came from and why such colossal hopes were placed on it. For German generals, the summer of 1941 was a cold shower. The Wehrmacht was used to crushing the enemy with relatively light equipment. Fast, well-coordinated units against armies that couldn't maneuver. But the T-34 turned everything upside down. No, Soviet crews in 41 used it poorly. There was no communication, tactics were primitive, supply lines were collapsing. But Berlin's engineers looked at the blueprints of the captured vehicle and understood. The T-34 was a concept they had no answer for at that moment. Sloped armor, wide tracks, a diesel engine, a combination that demanded a serious response.
The assignment for a new tank was issued to design bureaus in November 1941. The technical specifications were ambitious, to surpass the T-34 in all parameters simultaneously. To take its strengths, add German optical precision, a long-barreled gun, and reinforced armor. Two companies participated in the tender, MAN and Daimler-Benz. Interestingly, the Daimler-Benz project initially appealed much more to Hitler himself. The vehicle resembled the T-34 in layout, with a diesel engine and rear drive sprockets. But the technical experts of the Armaments Office settled on the MAN design. It was more traditional for German tank building, better suited the existing production base, and allowed for the use of proven components. In May 1942, MAN received the order. And here begins the part of the story that is usually glossed over. The technical specifications called for a vehicle weighing around 35 tons. By the final version, the tank weighed 44 tons, a difference of 9 tons. That's not just a number. It's a death sentence for the transmission, the suspension, and any bridge along the route. The German road network was built to handle axle loads typical of civilian transport. Most bridges in France, Italy, and the occupied territories of Eastern Europe could not support a Panther without prior reinforcement. To move a tank regiment, every route required reconnaissance and engineering surveys. This sounds like a minor technical detail, right up until the moment when an offensive must begin at dawn, and the only bridge across the river collapses under the weight of the third vehicle in the column. Everything on the outside was indeed impeccable by 1943 standards. The 75mm KWK-42 gun with a barrel length of 70 calibers could penetrate the armor of Soviet tanks at ranges where Soviet guns could not yet respond in kind. The front hull plate, 80mm sloped at 55 degrees. The light sight with tenfold magnification gave German gunners an advantage that in battle meant the difference between the first shot and the second. On paper, on the proving ground, on parade, it was a magnificent machine. But beneath that beautiful skin lurked a completely different beast. By the way, friends, don't forget to like the video after watching, or dislike it if you disagree with something.
The German military industry by 1943 was operating at its limit. The Panther Ausf D, the first production modification, was created under conditions of severe shortages of quality alloy steel, skilled workers, and, most importantly, time. Time that Hitler would not grant. General Inspector of Armored Troops Heinz Guderian pleaded for a delay. In early 1943, he personally reported to Hitler that the Panther's transmission would not withstand the loads, that the tank was raw, that it needed several more months of refinement. Guderian, the man who, better than anyone else in the Third Reich, understood how armored vehicles performed in combat, stated plainly, "This machine is not ready." He was not heeded. Operation Citadel was scheduled for July, and the Panther was to be its main symbol. We are often told about the Battle of Kursk as a great tank battle where two doctrines, two steels, two intellects clashed. That is true, but if you dig into the German frontline reports of the OKH, the Oberkommando des Heers, or Army High Command, most of which are now available to researchers, a different picture emerges. One of those pictures usually kept off the display shelf. By the start of the operation, the 39th Panzer Regiment under Lieutenant Colonel Lauchert had about 196 Panther Ausf D machines at its disposal. This was the new tank's combat debut. Hitler personally insisted that Kursk be its baptism by fire. On July 5, 1943, the offensive began.
By the end of the very first day of fighting, about 40 machines were out of action due to technical failures, and this with almost zero contact with Soviet anti-tank defenses. Fuel lines caught fire. Half shafts of the final drives snapped. Maybach HL 230 engines overheated and seized, a vehicle with a boosted engine designed structurally for normal operating conditions, not for the July heat under the load of full combat weight. By July 10th, the first 5 days of the offensive, of the original 196 Panthers, fewer than 40 remained operational. Non-combat losses exceeded losses from Soviet fire. I have long worked with German archival documents from this period, and here's what always throws me off track. They recorded everything themselves. This is part 1 of 3. In the reports of company commanders, detailed tables of breakdowns. In plain language, vehicle number such and such, cause of failure, destruction of the final drive's pinion gear. Distance traveled before failure, 17 kilometers. 17 kilometers. German engineers saw this. German generals read this. And still, they gave the order to advance. But the human side of this catastrophe gets lost behind the numbers. One can grasp its scale only by trying to imagine what it meant to sit inside a Panther in those days. A crew of 5 men. The driver, in the tightest compartment, with the levers of the ZFAK 7-200 gearbox on both sides. German drivers in post-war interrogations described operating this transmission as a constant feeling that the gearbox was about to rebel. Every gear shift on an incline was a lottery. Every pivot turn was a risk. The temperature in the engine compartment during a prolonged march exceeded 100 degrees. Unlike the diesel engine in the T-34, the gasoline engine allowed no margin for error. The slightest leak in a fuel line near the red-hot exhaust manifolds, and the crew burned. And the fuel lines on the Panther Ausf D leaked regularly. Amidst all this, the tank commander looked through his superb optics at the battlefield, saw Soviet tanks at 2 kilometers, and knew his gun could reach them. It was a bitter irony. The best sight, the best gun, sufficient armor, all mounted on a machine that could at any moment seize up or burst into flames without a single enemy shot. Here lies the paradox of this machine in concentrated form. The gun allowed for accurate fire at ranges where Soviet equipment was practically powerless to respond. The optics allowed for spotting targets first. The frontal armor held against most Soviet shells of 1943 at typical combat ranges. But the vehicle might simply never reach its firing position, or catch fire, or grind to a halt with a destroyed final drive. Here we must pause and say what most popular analyses of the Panther shyly gloss over or relegate to the end of a video in fine print. The German military tradition, qualitative superiority over quantitative production. Tigers and panthers against the 34s from Soviet factories. A beautiful concept. However, technical historian Thomas Jentz, in his fundamental study Panther and its Variants, based on German archival data, cites statistics that shatter this myth from another angle. In July to August 1943, during the most intense fighting at Kursk, non-combat losses accounted for 50 to 60% of all Panthers knocked out. Every second Panther was lost not to a shell, it broke down. This is not a random footnote in history. This is a systemic problem rooted in fundamentally different approaches to military production. German designers creating the Panther were solving a task that can be formulated as follows. Create a tank that surpasses all competitors in a single one-on-one duel. Soviet designers developing the T-34 were solving a different task. Create a tank that could be produced by the thousands at evacuated factories in the Urals, in the cold, with untrained workers, with minimal tolerances, with interchangeable parts. This does not mean Soviet designers were smarter. It means they worked within a different system of priorities. One Panther under ideal conditions was more formidable than two T-34s, but the Panther never fought under ideal conditions. It fought in mud, in frost, on shattered roads with overburdened repair services, and under these conditions the arithmetic began to work against it. The Panther Ausf D had a transmission developed by MAN concurrently with the tank itself, without a full test cycle, without refinement on prototypes under real loads. The final drive, the side reduction gear, was designed for a 35-ton vehicle. The actual tank weighed 44 tons. This is not a margin of error. This is 9 tons exceeding the calculated heat, exceeding the calculated torque, exceeding the calculated lifespan of every gear. Add to this the rush of production, and you get what happened at Kursk. The final drives on early Panthers failed after just 150 to 200 kilometers under normal operation. In combat conditions, with intensive maneuvers on rough terrain, this lifespan shrank to a few dozen kilometers. The repair crews of the 39th Regiment worked around the clock and still couldn't keep up. Vehicles stood by the roadside with their engine compartments open, not burning from Soviet shells but simply broken. In my opinion, this is one of the most telling stories about what happens when political pressure overrides engineering logic. Guderian knew the transmission was raw. Factory testers knew. Regimental commanders knew. The documents recorded it in plain text. But there was an order. There was Operation Citadel. There was Hitler, who wanted to see the newest German tank in battle right now, and the machine went into battle raw. Kursk became the turning point. Subsequent modifications, the Panther Ausf A and Panther Ausf G, launched into series production in 1944, received improved transmissions, reinforced final drives, and an enhanced cooling system. The fuel lines were redesigned. The problem of spontaneous combustion during unloading became rare. The lifespan of the final drives increased manifold. By 1944, the refined Panther truly became what it was intended to be: the best medium tank of World War II in terms of combined firepower, protection, and accuracy. Many historians characterize it exactly as such in relation to the late modifications. Soviet anti-tank crews at Lake Balaton and during the Vistula-Oder offensive knew well, if a silhouette with a long barrel and a characteristic frontal plate slope appeared on the horizon, it was not a T-4, it was a Panther, and letting it approach effective firing range was absolutely out of the question. The Western Allies received a similar lesson in Normandy in the summer of 1944. American Shermans and British Cromwells were technically inferior to the Panther in all key parameters: gun, armor, optics. It got to the point where American crews gave the Panther nicknames that are awkward to quote in polite company today, but the meaning boiled down to one thing: this machine must be avoided. Don't get into a head-on clash. The Allies developed tactics where one Sherman would distract the Panther's attention from the front, and almost certainly burn, while two others flanked it. An effective scheme. A cynical scheme.
a scheme that relied on the fact that Shermans were produced by the thousands and Panthers were not. This is where the harshest truth about productivity as a strategic weapon manifests itself.
By the end of 1944, factories in the Soviet Union were producing an average of about 1,200 tanks per month. American and British factories combined produced comparable volumes. By this time, Germany, under maximum strain, was producing all Panther variants combined at a rate of about 350 to 400 units per month. The productivity gap meant that each lost Panther was incomparably harder to replace than each lost Sherman or T-34. During the same period, the Soviet side increased production of the T-34-85 and supplemented its fleet with the Su-100 self-propelled guns, which were specifically designed with the expectation of engaging Panthers in combat. The 100mm response of Soviet industry to the German 75mm gun on simpler, more reliable, cheaper-to-produce vehicles. Herein lies the main lesson that the Panther's history delivers in the harshest possible format. A tank that breaks down on the way to the front is not a tank. A gun that cannot fire because the vehicle has stopped with a transmission failure 5 kilometers from its position is not a gun. Optics that allow seeing a target at 2 kilometers are meaningless if the engine catches fire when trying to climb a slope. Combat effectiveness is the product of all parameters simultaneously, and if one of the factors is 0, the result is also 0. But there is another angle from which this story is usually not considered. Allow me to state it directly because it is important for understanding why Germany found itself in a situation where its designers had to make such a choice in the first place. By 1942, Germany was waging war on several fronts simultaneously. The military industry operated in a state of constant emergency. The design of the Panther, the production of prototypes and testing, all of this proceeded in parallel, not sequentially. Under normal circumstances, between the approval of technical specifications and serial production, no less than 2 to 3 years of full-scale testing passes. The Panther traversed this path in a year and a half. Designers identified defects right on the production line and implemented fixes there as well. When a vehicle goes into its first battle without undergoing full endurance testing, that is not a forced strategy, it is an adventure. The German military industry knew how to make superb individual components. The KWK-42 gun was a ballistic masterpiece for its time. Light's optics were the envy of all warring parties. The Panther's frontal armor withstood shells that would have turned T-34s into burning torches. But behind these superb details lay a systemic error. The attempt to create a perfect tank under conditions where Germany could no longer afford perfection, neither in time nor in resources. And this is what remains when you view this episode in its entirety, from the drawing board to the burning machines at the Belgorod railway platforms. The Panther was perhaps the best medium tank of World War II, but it entered history in 2 guises simultaneously, as a symbol of German engineering prowess and as a symbol of what happens when that prowess is subordinated to political pressure rather than engineering logic. The same machine, depending on the variant and year, could either be a genuine nightmare for the enemy or a column of burning scrap metal by the roadside even before the battle began. The question I leave open: can a tank even be considered successful if its phenomenal gun and armor could never compensate for its inability to reach the front line in time? Or is the Panther still a success, albeit a belated one? I await your arguments in the comments. Among those watching me, there are surely people with serious knowledge of the hardware. If I missed an important detail, correct me right there. And do rate the episode, like or dislike. The choice is yours. This is Part 3 of 3.